Ready to master Python for data science? Want to become a top tech business analyst? Bridge the gap between data and business strategy. Subscribe to Query to Career and start today.
Measures of dispersion tell us about the spread of the data. We'll be discussing three measures of dispersion. First is range, second is standard deviation, and third is variance. Variance and standard deviation are related by a simple formula, that is, variance is the square of standard deviation. Let's look at range first. Range is simply the largest value minus the smallest value. So in our example, the largest value is 34 and the smallest value is 7. So the range is 27. But as we discussed for mean, range is influenced by outliers. So if your data has outliers, range should be avoided. For example, in this data only, if you had one value which was exceptionally high, for example, its value was 150, then your range would be 150 minus 7, which will be 143. But this range will not be a correct representative of the dispersion in this data. Since only one value is exceptionally high, other values are more or less confined to a small range, which is 7 to 34. So that's why if your data has outliers, try to remove the outliers before finding the range, or else don't use range as a measure of dispersion. We will discuss this further when we are preparing our data for analysis. So there will be a separate section on data preprocessing that will be discussing it in further detail. Next is standard deviation and variance. Variance is the average of squared differences from the mean. So x minus mu is the difference from the mean. So where mu was the population mean as we defined earlier, x is the value of each observation. When we do x minus mu, it is the difference of that particular observation from the mean. We square all such differences and then we find the average of it. When we do it for the population, we get population standard deviation. For population standard deviation, the formula is as per the definition only. But if you are estimating standard deviation of population basis a sample, the formula has n minus 1 below. We will not discuss the proof of how this becomes n minus 1, but in short, this is because when we create all such possible samples, the standard deviation of all these samples should come out to population standard deviation. That will happen only when there is n minus 1 here instead of n. So just remember this. You could probably imagine that larger sigma value means data is more widely distributed. So let's calculate the standard deviation for this data. First we have to calculate the mean. Mean for this data comes out to 24.875. Then we find the variance, which is defined as sum of square of distances from mean. So for the first value, which is 10, we find the difference from mean and we square it. Then we take the second value, find the difference from mean, we square it, and we add all these values and we divide it by the total number of observations, which is 24. So we get 1624.625 divided by 24, which comes out to 67.69. This is the variance. We do a square root of this value to get standard deviation. Square root of 67.69 is 8.23. So standard deviation for this data is 8.23. So the larger this value, the larger is the dispersion from the center. So if you get another set of 24 observations which has similar mean but has lower value of standard deviation, that means that data has less dispersion in it and the values are closer to the mean. And if you have a data which has larger standard deviation, the values are further away from the mean.